So, all right. So this is 6.6, section 6.6. And again, I have to say hi to hockey players and anyone else that's missing class, and anyone else that ends up just listening to this. But this is on section 6.6. We're dealing with rational and irrational numbers. And what I want to do is just we talked about them before, but you need to be able to identify these. And so I want to show you a couple things quickly. First is that let me just go ahead and categorize rational. Rational numbers, like the most precise definition is any fraction or any number that can be expressed as a fraction of integers. What's an integer, by the way? Number. Be more specific. Pi is a number. What is an integer? What's that? Go ahead and look up here. You guys don't need your computers, all right? Go ahead and tilt your computers toward you. Exactly, all right? It's okay, so any number that can be expressed as a fraction of integers.
Can we write that down?
Sure.
Should we? Is it?
Yeah, you'll be tested on it. So whatever, going to be quizzed and tested on it. It's a fraction of integers. And in a couple examples would be, an example would be something like 4 over 5. 4 over 5 can also be expressed as 0.8. So oftentimes we can have rational numbers expressed. Actually, we can always express rational numbers as a decimal. How about 1/3 though? What is 1/3 as a decimal? Anyone? Want to put it in your calculator?
0.3333.
Yeah, it's 0.333. When does that stop? So, but that is that still a rational number if it continues forever? Yeah. So in two cases we either have fractions as decimals will either become terminating decimals, which is this case here, or they can become repeating decimals. Another example, does anyone have a calculator out? Can you please put your computers away? Tilt your computers down, all right? Keep trying to tilt them down until they all go all the way down, because I'm not going to put up the computers right now, all right? Close your computers, thanks. Okay, very good. Close your computers for a moment. So, rational numbers are any number that can be expressed as a fraction of integers. Examples, 4/5, which can be expressed as a terminating decimal, 0.8. Repeating decimals also are part of the rational numbers. All right? Any number that repeats, even a pattern of 0.2, 0.2, 0.2 would also become I'll give you another example. 0.123, 123, 123. Because the decimal repeats itself, it would also be considered a rational number, which means, of course, that if you have the algebra to do it, I'm not going to show you, you can actually create a fraction of integers with this. So, actually, I'll show you the technique, because there's one cool thing about this that I would like to demonstrate. Actually, let me do it right now. So, next is following, is that a rational number is any number that can be expressed as a fraction or in decimal form as a terminating decimal or a repeating decimal. That second part that I added, am I still working? Okay, good. So based on that, tell me, here's a question for you. Based on what I just said, is 0.999 repeating rational?
Yeah.
So that means it can be expressed what? In what way? A fraction of two integers. I wonder what that might be. Let me show you let me show you how to find what this fraction looks like.
9/100.
So what you're going to do, 9/100 is a good guess. It's 99/100 or something like that.
99 999
Over 1,000? 999 over 1,000? Am I working now? Okay, sorry. It really does go on forever. So you'd have to go, you have to have a whole bunch of nines on the top. So let me just show you what I'm going to do. I'm going to say, I don't know what it is as a fraction. So what I'm going to do is I'm going to call it x. And come on, buddy. So I'm going to say, I'm going to let x equal, I'm going to say x is equal to 0.999. Let me get some more space here. Yes?
I have to go now.
Yeah, go ahead.
Good luck.
Thanks.
No.
So, so x is my unknown, and I'm going to say I'm trying to figure out what x is. All right, and so x is 0.999. Let's figure out what that is. The way to do this is I'm going to multiply both sides by 10. If I multiply x by 10, what do I get? 10x. If I multiply 0.99999 by 10, I get 9.999 repeating. That, make sure you believe that. If I multiply by 10, that moves the decimal place once to the right, correct? Mm-hmm. So if you remember from the beginning of the year, and we'll be doing it later, when we solve systems of equations, if we have two equations that are equal, right, both of them are equal, then we can subtract one equation from the other, and they will be equal. So let's do that. 10x minus x is what? 9x. Now, on this one, what I have is this 9999 repeating into infinity, right? And over here, I have 0.999 repeating to infinity. What's going to happen when I subtract this 9.99 to infinity from this 9.99 from infinity? What do they do?
No, you just have 9.
I just get 9.
Really?
Therefore, x is equal to 1. So what we just said is that what we said is 0.99 repeating is equal to 1.
Or just round.
That's not rounding. It is exactly equal to 1. The point on the number line, 0.999999999 resides exactly at the integer 1.
But isn't that before? But it doesn't.
Thank you for being bothered. But this is true.
It's not.
This is not an approximation.
But it's right before. Wouldn't it be like right before?
Right before what?
1. 0.1 before.
Then
No.
why don't we just call it 1?
Point 1 before?
It's 0.0000000.
This is where you guys have to deal with the concept of infinity. The only reason you think this is an approximation is that you think somewhere at infinity, the series of 9s disappears. But the series of 9s never disappears.
And it's not 1
It
yet.
continues to go on forever. When I multiply this by 10, it's not like it's taking away a space from infinity. What is infinity minus 1?
Infinity.
Infinity. So this used to bother me. This is the technique for taking a repeating decimal and turning it into an integer. I put this one on here deliberately because this is one of those places where math enters this very strange world. When we sit there and say that the number of decimals past the 9 here is bigger than the number of 9s going to infinity here, we make an error. It's incorrect to say that. So this forces us to deal with infinity in a very puzzling way, doesn't it? Mm-hmm. But this is, just so you know, is absolutely not an approximation for 1 any more than 0.33 infinity is an approximation for 1/3. That is a ratio of 1 to 3, right? 1/3. That's 33 over 100. Is that exactly a third? No. It's only when you take 0.33 to infinity that we get 1/3.
I don't get this.
Anyway, the point is this. The only point that's important here is that we recognize about the this. That's just a bonus discussion based on the same idea. All right. So the next thing too. What's that?
Would that be like a bonus question?
That would be an interesting bonus question. But yeah.
Ted, just so you're aware, on one of the questions.
So if I know what I want to do is I'm sorry about that. Yes, Claire.
Well, you didn't seem to care when you cut me off, but okay.
I thought I was speaking, but anyway, go ahead.
Fine, never mind then.
Okay. What I want to do someday though is I'll give Claire a grade of 99 at some point when she gets when she does really well in this test. I give her a 99.9 to infinity %. What is that?
100.
That is 100.
Okay, so give me the.
It is 100.
99.9. Okay, that was
Just because you don't want it to be 100 doesn't mean that it isn't. But anyway.
Remember when you wrote on my paper 74 and I actually got a 93? That made
Oh yeah, that was an accident.
That was not
Okay.
That was just.
Wait, is it actually?
Yeah. Let me. How did I get back here?
Radical 7.
The other form of numbers are irrational numbers, and again, if you use your calculator, this is that can be really helpful. But irrational numbers are numbers that are not. Sorry about that. Irrational numbers. What is an irrational number?
A number.
It can't go to like a fraction. Like
It cannot be expressed as a fraction. It sounds terrible, but it's any real number that's not rational. So it's any real number that's not rational. Okay, you're being recorded, goofball. And these people are gonna. Okay, so basically, it means it's a number. It's any number that cannot be expressed as a fraction of integers, and is not a terminating or repeating decimal. And a couple examples would be just one of the most popular examples is this number pi. If you put it in your calculator, and you had a zillion decimal places, it would fill up your whole screen. It never repeats, never terminates.
I wish it repeated.
Yes.
Then we wouldn't have that special day.
Can we work on a classwork?
What's that?
Can we work on a classwork if we understand?
What do you think?
When I'm done, we can do that. So I'm almost done. All right. What other numbers? Can you give me another? Because you understand, can you give me another number that's irrational?
Phi.
What's that?
PHI.
Oh, we just did that.
PHI.
Oh, what number's that?
Phi.
It's like an O with an I in the middle.
I know, but that's the letter. Actually, it's a Greek letter.
You mean theta?
It can be like represented by like 1 plus rational.
I wasn't trying to. I wasn't trying to. I swear that these. I'm just saying that these have to be actual numbers. Another number's. What's that?
-1.
-1 would not make it.
Why? What's -1 in a fraction?
0.
-1
-1 over 1.
Oh.
You want an irrational
Zero.
number?
0 over 1 would be rational.
You want an irrational number?
Okay.
Give me 1.
0.
Okay. 1 over 0. That would not. That's undefined. Okay. Can you guys think of any other numbers that don't terminate?
An
Yeah.
irrational number?
7.
What's that? Any-
Radical
Do you want to know an irrational number?
Yes, I do.
It's the baby 5, radical 12. That's an irrational number.
Okay. Radical 2. Thank you. Okay. Square root of 2. Square root of 7. All right. The cube root of 9.
Square root of 5. Yes.
The cube root of 9. All right. Any radical that does not simplify into a rational number is also irrational. If you put them in your calculator, they will fill the screen with digits that never repeat and never terminate. All right. So I just want to make sure we know that. Okay. For the rest of us, and that's okay. At this point, you guys can go ahead and start the classwork. And then I need to tell hockey players, for one, and my D block class. Hi, D block. Hi, D period.
Oh my gosh.
I feel like he feels like a YouTuber or something.
Yay.
He hates
Yeah.
that
Hi
class.
guys.
Okay.
Welcome back to my channel.
D period. Do I love you more? No. They're gonna say no. I'm sure they. Okay. Anyway, D period. Just so they know, you guys missed this because it took me most of the period to get this thing working. What you guys need to do? What you guys will need to do is do what, guys?
Do the work.
Go on to My Essay. Go on to. Go on to My Essay. And what does it say, guys? What's the title of the assignment?
It says
Something classwork. Just the thing that says
It says
class.
page 200.
It just says classwork.
it says class task.
Okay, class task.
And
It says
in
the page number and
in classwork, it tells the page number, the thing. Or what's the other way to find out what questions there are?
Email.
Yeah, if you guys open the, if you go on your My Essay, open the classwork, and then open what does it say? Questions and answers?
yeah, it says blue is the circle classroom.
Right.
And then red is the
So open the attachment assigned, associated with that attachment.
There's been a mistake.
Mr. Shy.
And you're gonna do the blue ones, right? Do circle questions. Circled in blue.
Oh, that's the one I have a question on, and then the figure. So what you do is you
For classwork.
both sides, the top and bottom, and then you get AI over.
And I'm gonna ask you guys to turn that in, all right?
cool. I have a question.
Classwork?
I
Yeah.
squared is -1.
Yes.
And then -1 is -3. So you get 8I over -3.
So you're gonna turn it in to the sub.
We have a sub.
I have a major question.
No, that's the D block class.
So we're gonna turn it in.
Mr. Shy.
Okay, D block. When you're done doing that, if you want, you can go ahead and start with your homework, and that's it. Outside of that, just make sure that you're being good to your sub, and I'll see you on Monday.
Help me on one of the questions, Mr. Shah.
Yes, I will. Did everyone say goodbye? Goodbye.
Bye, Yuho.
Yeah.
Bye, Yuho. Do you know who that was? Okay. Is this thing working? Yes.